Hey guys, we're going to be continuing Chapter 8, Section 4 here, talking about transformations and congruence. So what you're going to learn is to describe a sequence of transformations that maps one figure onto another. And then you're also going to be able to determine whether two figures are congruent by using a sequence of transformations. Let's go ahead and jump in here. So it says the three trapezoids are congruent. Describe the sequence of transformations that maps WXYZ onto W double prime, X double prime, Y double prime, Z double prime. That's a mouthful. So how do I get this one to this one? All right, so the first thing is I would say a reflection. This flips over here. So reflection of WXYZ onto W prime, X prime, Y prime, Z prime. That would be the first step. So that gets this from here to here. Now how do I get from here to here? Well, it looks like it slides. The orientation doesn't change. So we would call that, reflection over the, we got to say what it's reflecting over the Y-axis. Then down here, this would be a translation down, let's see, how do I get from Y to Y prime? Well, 1, 2, 3, 4, 5, 6, 7, down 7 units. Onto W prime prime, X prime prime, Y prime prime, Z prime prime. All right, so in other words, to kind of shorten this, you need to write all this out. But I'd say, well, I'd reflect over the y-axis, then I translate down 7 units, which maps this onto that is the language that we would use. So this is all you're doing for this particular one is just describing what transformations you could use to get from one figure to another. So here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here's what I got. I said a translation 7 units up, then a reflection over the y-axis. Hopefully you got the same thing. If not, go back and find your mistakes. Let's keep moving. But first, we need a barnyard photobomb. Nothing like a good photobomb from out on the farm. Look at that horse. He got stuck, and the cow is bombing that photo. That's hilarious looking to me, by the way. Okay, so using transformations to determine congruence. It says determine whether the two triangles are congruent. If they are, write a congruence statement. If they are not congruent, explain why. So we need to think to ourselves, well, how can I get from this to this? All right, is there any particular way I could do that? So the first thing that I need to recognize is that they are on opposite sides of the y-axis. So let's go ahead and get this figure over on this other side. I'm going to change my ink color here so it's a little bit easier to see. So I'm going to go ahead and just flip this. So I'll put B prime here, and then we'll leave A prime where it is because I'm reflecting over the y-axis. So here's C prime. So here's my new triangle. Now how can I get it down to here? Well, this triangle is oriented a little bit different than that. So if I rotate this 90 degrees about the origin, in other words, if I just rotate it down this way, well, it gets pretty close to here. So let's see. This one is on 3 here, which means it's going to be 3 here. We'll call that C prime prime. This A is on the 3 there, so it's going to go here. So we'll call that A prime prime. And then this right here is a little bit trickier. It's back 2 and up 4, which means this is going to be back 4 and down 2. So that's B prime prime. And I end up getting a shape like this. Well, it looks really similar to this, but let's go ahead and see what happens. If I went down and translated down 1, then I would have this is right here. Translate that down 1. That's right there. Translate that down 1. And if you could use transformations to get these figures to line up perfectly on top of one another, we'll call that B prime prime prime. This will be A triple prime. I know I'm kind of messy here with my writing, but there's not a lot of space. This lines up perfectly with this. So I need to write a congruence statement. The reason I labeled all these is because now I'm able to write a congruence statement based on these image titles. In other words, Y lines up with B, A lines up with X, and C lines up with Z. So I would say that triangle ABC is congruent to triangle, let's see, A goes along with X, B goes with Y, and C goes with Z. Remember that order matters. And then my explanation is right here, all right? So I have a reflection followed by a rotation followed by a translation. If I could prove this and show this on the coordinate plane, then that is a pretty solid explanation of this. So for the sake of time, I'm not going to, but you should probably write that out. In other words, you'd say reflect over y-axis. I'll just go ahead and write it out. We got that. Reflect over y-axis, 90-degree rotation about the origin. And then I would say a translation down 1 unit. All right, so there is my explanation that just says, how do I get from this figure to this? So here's one for you to try. Go ahead and pause. The answer will be up in 3, 2, 1. All right, so here's what I got. Triangle EFG is congruent to MNP. Make that M a little easier to see. And there's a couple, there's multiple ways, but one way is you could reflect over the y-axis, translate down 6. You could reflect over the x-axis, rotate 180 degrees, and then translate down 6. You could reflect over the x-axis and then rotate 180 degrees about the point 0, -2. That one would be really tough. If somebody saw that, I'd be really impressive. But there's multiple ways to get from here to here. The point is just to be able to get from there to there to show that they are the same. And that's it for today. So hopefully you took good notes. I'll see you all in class.